Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find the green shaded region area? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. Find the green remainder inside the quarter circle. The only unshaded piece is triangle EBD, so we will recover the radius and then subtract that triangle. The arc from A to C is a quarter circle centered at B. Therefore, segment BA and segment BC are perpendicular radii of the same unknown length r. The two given lengths are segment EB equals 5 and segment BD equals 7. They are perpendicular because they lie on the two radii through B. At E, the two marked segments, segment ED and segment EF, are equal and perpendicular. This rigid corner transfers the known 5 and 7 to the remaining construction. Let P be the foot of the perpendicular from F to segment AB. This creates a 90-degree triangle EPF beside the given 90-degree triangle EBD. Angle DEB equals angle EFP because each angle is formed by a pair of respectively perpendicular lines. Our first insight is that the equal perpendicular corner creates congruent 90-degree triangles. They have equal hypotenuses, segment ED and segment EF, and a matching acute angle. Corresponding sides now give segment EP equals 7 and segment PF equals 5. Along the same radius, segment BP is segment BE plus segment EP. Thus, segment BP equals 5 plus 7, or 12. Triangle BPF has a 90-degree angle at P and legs 12 and 5. Its hypotenuse segment BF reaches the circle, so segment BF is the radius. Our second insight is that the transferred lengths form the 12th of May 2013 radius triangle. Pythagoras gives r squared as 169, so r equals 13. The quarter circle area is 1/4 pi r squared, so it is 169 pi over 4. The unshaded triangle EBD has perpendicular legs 5 and 7, so its area is 35 over 2. The green remainder is the quarter circle minus triangle EBD. Subtract 35 over 2 from 169 pi over 4. Therefore, the green area is 169 pi over 4 minus 35 over 2. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.